Welcome. From today onwards, we are going to start a new topic, that's the fluid mechanics. That's a whole subject for us, and we will be covering it for GATE and engineering services. And this topic will be beneficial for civil engineering as well as mechanical engineering. So let's start, and let us understand about what are the contents that we are going to cover in this fluid mechanics. So if we talk about the contents, then the first topic that we will be doing will be basic concepts and fluid properties, and then second topic will be our fluid statics. In this we will be covering about pressure measurement, hydrostatic forces and flotation buoyancies. Alright, and then the third topic will be fluid kinematics. After fluid statics we will jump to fluid kinematics, and then we will go for fluid dynamics, and in this we will study about application of Bernoulli's equations and all. Then the fifth topic for discussion will be the laminar flow, and after that we will be covering boundary layer theory, and then after this, and this is the very important topic, and then after this we will do flow through pipes. At last, the eighth topic will be our turbulent flow. We will do this at last. So these will be the 8 topics that we will completing in this module of ours. So stay tuned. All right, let us now start to understand that what is the nature of the subject that we are dealing this time. So if we talk about mechanics, there are 3 types of mechanics in it. The first one is engineering mechanics that we all study in our first year of engineering, and then there is second type, that is strength of materials, SOM, and then comes our favorite, fluid mechanics. So this is the category. So mechanics, this, SOM and fluid mechanics. Alright, so what are these things? So if we talk about them, then in engineering mechanics we talk about rigid bodies, and in strength of material we talk about deformable bodies, and in fluid mechanics, of course, as the name suggests, we talk about the fluids and the mechanics. So what are the rigid bodies? So just for an example, if you are given with an object A, B, and say we take 2 points in this object which are at a distance of say x, distance between these points is x. Now if I apply compressive force or a tensile force on this object, even after application of these forces, if the value of this x, that is the distance between the consecutive or adjacent molecules, is not changing throughout the application of forces, external forces and loadings, then such object is a rigid body. Now like this. So now similarly, if due to the application of force the distance x varies, then this comes under the deformable bodies. So we can write it, if x varies due to external force, it's all deformable bodies. And in fluid mechanics, of course, we talk about the fluid, and you will learn what is fluid in detail right now. So if we further categorize these things, then we will come to know about that there are more classification to it. One of the classification is known as static, and another classification is known as dynamic. Alright, so of course the name suggests, the static means the body at rest. In static, the body is at rest. In dynamic, the body is in motion. And then this static motion is again of two types. One we call kinetics and one we call kinematics. So what is this? So in kinetics, we talk about load and its effects. Load and effects. But in kinematics, we only deal with effects. For now, just try to understand what I am writing over here. You will go through these topics in detail and try to witness what all these things actually means. Let's start with the first topic. The first topic is the basic concept and fluid properties. So in this, the fluids are substances, the fluid are the substances that have ability to flow. So fluid are those substances which have ability to flow. Or deform continuously. So the fluids are the substances that shows the ability to flow or deform continuously under the action of shear force. Now if we try to understand it, what it is saying is, for example, if you have any object like this placed on a table, right? Now if you apply a shear force at this point on the solid object, and let's assume that it is made of rubber, we can say for our ease we say it is made of rubber, then due to its elasticity, what it will do, it will deform something like this, right? It will deform something like this. If the shear force has been applied like this object will deform like this. Then as soon as the shear force is removed from this point, then this object will try to regain its original shape. This is what elasticity means. So in solid cases, as long as the shear force is being applied, the object will remain in its deformed shape. As soon as you remove the shear force, it will again regain its original shape. But this is not the case in fluids. So in fluid, if you apply a force, a shear force on any particle, then it will keep on deforming continuously. Now what does this mean? Now, for example, again there is a ground and you got a fluid flowing like this. Right. Now if I take this cross-sectional area and I say there are some molecules over here. Now if I am applying the shear force over here, the shear force is like this on this molecule. Now if you will apply a shear force on this molecule, then this will move till here and it will keep on deforming, it will keep on flowing in this direction even if you remove this shear force from it. So we can say that in this, the deformation is varying with respect to time. Fine. Now if we watch closely to these molecules, what does it says is, this molecule is, you can see, in the contact with this boundary. This is a boundary. This molecule is in the contact with boundary. So at this point, there will, we assume it that this molecule will not be moving. So at this point there will be a no slip condition. Fine. Now a molecule just above it will be held back or will be restrained moving in this direction because of this molecule. There will be some intermolecular forces because of that. So we say that it moves a little bit distance like this, but this molecule is far away from this, quite far as compared to this distance. So it will come, we can say it will move till here, this will move till here, and we say this move till here. So what is happening is that the molecules that are closer to the boundary are deforming less, and that are away from the boundary, that are away from the reach of intermolecular force from this boundary region, are deforming more. So there will be the more angle of deflection on the movements. So now since the deformation is continuous over here with respect to time, so instead of talking about this angle, we talk, this was the angle, right? Instead of saying the angle, because it is not at all constant, we go for the rate of deformation. This theta used to give us the deformation, right? This was the angle in the solid case, this was the angle, this used to give us deformation. But in this, there is no constant deformation, it will keep on deforming, so we will get the rate of deformation. Therefore we use rate of deformation in the case of fluids, and this can be expressed as d theta upon dt. Our next topic is what are the differences between solids and fluids. So the first difference will be that in case of solids the deformation is constant, so we can write it like, in case of solids the deformation is constant. Yes. So in case of solids the deformation is constant, and in case of fluids the deformation is varying with time. So therefore in case of solids deformation is important, and in case of fluids the rate of change of deformation is important. That means d theta and upon dt, this is calculated. The second difference is in case of solids, on removal of load or what we call the shear force, the solid will try to regain its original position, as we have discussed this just before. Whereas in case of fluids, on removal of the load, it will never regain its original position. So we can write it like will so in fluids it will never regain its original position, it will keep on continuously deforming and deforming.